This is Precalculus, Chapter 1, Lesson 1, Number Patterns. All right, for this lesson, we want to make sure we define the terms, you understand the vocabulary, and we're going to look at the complex system of numbers and how they are visually represented. All right, so this is review from long ago. In the complex numbering system, we have real numbers, and what's the only one that's not a real number? What? Oh, irrational is a real. What's the only number? What? There's only one of them. If it's not real, it's imaginary. Make sense? Under real, we have irrational, we have rational, and I'm only going to go down as far as integers. All right, what makes the number irrational? Come on, ladies and gentlemen, what makes a number irrational? It has unending decimals, like pi. And they're non-repeating. Unending decimals where there's not a pattern. It doesn't repeat. Yes?
Wait, so you're saying rational numbers are irrational numbers? Like a type of irrational?
No. Don't. If rational should have been.
Or substitute.
Yeah. All of these are reals.
Oh.
All right. Does that make sense? All right, rational. What makes a number rational? Come on, ladies and gentlemen. You're in Precalculus. Talk to me. What makes a number rational? It can be represented as a fraction. It has terminating decimals. Or repeat decimals. There's a pattern. What's an integer?
Whole numbers.
Only whole numbers. All negatives, 0, and all positives. Only whole numbers, integers. In fact, I was doing an ACT test just yesterday, and it said how many integers are between 65 fifths and I don't even remember what the other one was. 30 fourths. That was a question on the ACT. How many integers are between those two? You know, to answer that question, you had to understand what integer was. That means only whole numbers. All right? Did you want to know the answer? I don't remember the answer. That wasn't the real problem. Ben has to take it in a week or two. So you can anticipate that, Ben. All right. How do we visually represent real numbers. Next semester, we will represent the complex number. Anytime you hear the word complex, think imaginary, because that's typically what the question is referring to. It's always an imaginary number. Even though all these numbers are complex, when you read the word complex in any textbook on the ACT, think imaginary. We will graph imaginaries on the polar coordinate system, which is very different from the rectangular coordinate system. We will graph real numbers either on a number line, if there's only one variable, like we're only looking at x greater than 2, less than 5, that's number line worthy. Or on the rectangular or Cartesian coordinate system. X, Y. When we get to polar, it will be x, I. Now that y can also be represented in another way when we're talking about functions. And what is that? Do you remember? Y can also be represented as in function notation. Do y'all remember? We could say that's f of x and that's x. So f of x is the same as y. And we're going to talk about function notation today. All right, so we're actually going to represent them. We're going to be given some numbers and we're going to represent them graphically. Why do you think that we would want to represent numbers graphically? What would be the reason that we would take these XY values and represent them graphically? And it's not just because you've been told to do it. It's to see if there's a pattern. Is there a pattern? Is there some relationship between X and Y such that we know that as X increases, Y is decreasing? All right, it's so important to see patterns in numbers. All right, so look at example 1. This is what we skipped last year. It's a scatter plot. And we're going to do scatter plots this year. Scatter plots are literally points on the rectangular coordinate system, XY coordinates. When you have years, your year is going to be your X value. And whatever the other term is, variable, is going to be your Y value. All right, your X coordinate is your domain. That's what it's called in your higher level math. Your X values are your domain. So when I ask you what's your domain, you're going to give me what the X values are. And your Y coordinates, they're going to be the range. Now when we graph with years, we decide the first year, 1988, that's going to be either year 0 or year 1. Yes.
Oh, no.
Okay. I'm going to make 1988 the value. I'm going to give it a value of 0 for X. You're not going to put 1,988 in your calculator for X. Got it? You're going to decide the first year represents 0. Then we're going to count up from that. So if I go from 1988 to 1990, what should be my X coordinate for 1990? If 88 is 0, 90 should be 2. Yes. Makes sense? And then 92 should be, and 96 should be, got it? 96 should be 6. All right? Does that make sense? Got it? All right, so I'm going to label my graph. 2, 4, 6, 8. Actually, it does go up to 8 because that's 0, that's 2. 92 is 4, 96 is 8. All right, 2, 4, 6, 8. Now look at my amounts. The smallest amount is 276, and we go to 500. So I'm probably going to count by hundreds on my y-axis. You could count by 50s, but I probably wouldn't be counting by ones. Actually, if you count by ones, I probably would mark it wrong because that's so illogical. Because you're not going to make 500 tick marks to get all the way. You get it? So be reasonable. So I'm going to count by hundreds. And we'll plot them. So for 1998, it's 276. Around there. 1980, it's 284. A little bit higher. 92 is 392, so it goes up almost to 400. 94 goes to 418, bumps up a little bit above 400. And 96 goes to 500. So it almost looks like stair steps, huh? Kind of, sort of. But we do see that as X increases, the amount, the millions of dollars contributed to congressional candidates is growing. It's not declining. And that is actually a true thing even today. All right, so look at example 2. Example 2 on page 6 says, the table below shows the heights and shoe sizes of 12 high school seniors. So height looks like has some relationship to shoe size. Would you agree? And so there are 12 ordered pairs. Here we had 5 ordered pairs. But with height and shoe sizes, we have actually 12 ordered pairs. So my X value is going to be the height in inches, and my Y value is shoe size. So I could write the order pairs. 67, 8.5. 72, 10. Got it? Making sense? 69, 12. I want us to do this one in our calculators and plot it. All right, do y'all remember how to do a scatter plot? All right, I'm going to remind you. Go to second, stat. Cancel that. Just go to stat. Stat, edit. And you have list 1 and 2. Do you have anything in list 1 and 2?
Yes.
Okay. So toggle over to list 1. If you go up to highlight list 1, hit clear and go down, it clears out the numbers. Make sense? Go over to list 2, toggle up, highlight list 2, hit clear, go down, and it eliminates you, or you can overwrite them. Your calculator will overwrite them. All right. So in list 1, I want us to put the heights. So enter 67, enter 72, enter 69, enter, and so forth. All right, you got it?
I accidentally got rid of my list one.
Okay. Okay, it's fine. Just enter the numbers in list 2. We'll just have to make a change. So your X values are going in list 2. Your Y values are going in list 3. All right. Everybody else go to list 2 and put the shoe sizes. 8.5, 10, 12, 12, 10. Is everybody good?
Me and Ben don't have it.
What don't you have?
We can't make those.
Stat, edit, edit. Boom, there it is. Stat, enter, edit. All right, how we doing? Get your list 1 and list 2 in. All right, how we doing? Tell me when you have your list in.
List 1's height and list 2 shoe size, right?
Yes, correct. List 1 is height, list 2 is shoe size, unless you're Hannah. Which is fine, not a big deal. We're gonna fix that, Hannah. No worries. I think we can just reset your calculator. All right, are we there? Okay, now we're gonna go plot them. So if you do second y equals, that takes you to the plot. Do y'all have the plot 1 turned on? Does it say on? Okay, hit enter on 1 and then highlight on. That's the first, okay? Mine is already highlighted. The second row should tell you what you want it to look like. Dots. We don't want lines. We don't want a histogram. We want the dots. I don't care what your dots look like. Okay, X list. All right, this is what you're going to change, Hannah. X list. Yours should be list 1. Hannah, when you get there, you're going to do second 2 to make it list 2. Your X value is going to be your list 2.
How do we get the graph?
And then your Y list should be list 2. And then whatever mark. Okay, is everybody set? Okay, now we have to think about window. Because remember, we tell this computer what we want to see in the window. So we have to think, what is our domain? What is our range? All right? So you go to window. My mode is not right.
Wait, how do I put the graph points into the calculator?
All right, if you go to, how do you put,
Right
Oh.
here.
that's it. Okay. And then did you do this? You're on. Okay, you're good. So now go to window. All right. All right, my smallest value, typically if I'm plotting something and there are no negative numbers, for X, what's my smallest x value? 62. So maybe I want to go 60 to 80. Does that make sense? Do you see how I decided that? Do you see how I decided I want my x min to be 60, my x max to be 80? And then toggle down to the y min, and the smallest shoe size is 5.5 and the biggest is 12. I'm probably going 0 to 20. So my y min is going to be 0, my y max is going to be 20. And then you hit graph to graph it.
I just set other pictures. Oh, I wonder if I did it doing that. I didn't put
All right, did y'all get it? Did y'all get it? Yes? It's probably because are your windows the same?
Wait, I'll do this.
Let's look at your, look, you don't have as many numbers to start with. You put in the first one. That's fine. That's fine. Don't worry about it. Don't worry about it. Okay, did y'all get something? Check values in the window, X min, X max. Okay. 60 to 80. Oh, look, your min is bigger than your max. Okay. Something wrong with the window. Okay, did you get something? Okay, don't ever, look. Somewhere I have another. Here. And I have, okay. Did y'all get something? Yeah, that looks good. All right, y'all, you all got something. All right, good. Let's keep moving. If I were to ask you on that problem, what is the domain? Here's what you would write. The domain is an element, and you'd write what the domain is without repeating the numbers. 62, 62.5, 64, and so forth. You got it? If I were to ask you, what is the range? Yes? Okay, I'm going to look for batteries. Then the range is an element of, what's the smallest? 5.5, 6, 6.5, and so on. Make sense? Domain and range. Okay, I think it takes 4 batteries. All right. Let's keep moving. Look at example 3. All right. Example 3 says to give the relation between those numbers and state its domain and range. And create a scatter plot. All right? So given the relation is 0 goes with 0, 1 goes with 1. Those are XY coordinates. So if I were to list the domain, my domain would be 0, 1, 4, 9. Y'all see that? 0, 1, 4, 9. What would the range be? Somebody tell me the range. All right, I'm going to start calling on you. Jonathan, what's the range? The range is not 9. Somebody else. Ben, what's the range?
Is it -3, -2, -1, 0?
2 and 3. Yes, yes. It's those values. Got it? Make sense? Okay. What makes a given relationship, XY coordinates, what makes a set of coordinates a function? Do y'all remember that from last year? What makes it a function? Avery, do you remember? You don't remember? Be honest. Yes.
Non-repeating x values. If they don't have the same y.
That's correct. Every x has one and only one y value. Every x has one and only one y value. Can y have multiple x's? But x cannot have multiple y's. Got it? All right, so looking at example 4, Ella, A. In that relation of those coordinate pairs, is that a function? And if it's not, then tell me why. Okay, does everyone agree that A is a function? Why, Peyton? Why do you not believe it's a function? Correct. X is repeated with different y values. So the x coordinate 1 cannot go with positive and negative 1y. It's not a function. Make sense? All right, Sam, B. Is B a function?
It is.
Does everyone agree?
Yes.
Jonathan, do you agree?
Yes, I agree.
Do you agree because you know, or do you agree because you're under peer pressure?
The second one.
Correct. That's what I thought. Okay. Do you understand why? Look at it.
I do know.
Okay, excellent. All right, Rain, what about C? Is C a function? It is. Because no x is repeated with the y. All right, function notation. Let's look at function notation. All right, so you understand scatter plots? You know how to do them in your calculator, you know how to do them on paper. If I give you a test and I ask you to do a scatter plot, do you think I'm asking you to do it on your calculator? The answer is no. I'm asking you to do it on paper. All right.
Is that for like homework too? Which
Homework 2 probably should be done on paper. Unless it says on your calculator. But they should be quick. And I have gone through every homework assignment this semester again, and made adjustments as I felt were needed. All right? All right. This is function notation. All right? What this says is substitute a value in for x such that you solve for y. So if I said f of 5, what is f of 5? Then what I'm asking you is, when you substitute 5 in for x, what's the y? This is asking what is the y value when x is 5. Make sense? So you would substitute it in. 2 times 5 plus 3. Make sense? If I said, what is f of x plus 2, then that says substitute that in where you see x. And simplify. It wants to know what is your output. It's going to give me coordinate pairs. This one's going to be what? 5, 13. This one's going to be x plus 2, comma, 2x plus 7. I mean, it literally is going to give me xy coordinate pairs. Make sense? Now, what matters is if I tell you f of x is x squared plus 3, and I want to know what's f of negative 2, you're going to do to negative 2 whatever the operation you're going to do to x. So, that is negative 2. That's what you are squaring. It is not negative 2 squared. That's a different value. Got it? All right, so we can do this with equations, but can we do this given graphs? So look at example 5. We have a graph. Do you see the very ends of the graph are closed intervals? Do you see that? You see the closed intervals at the very end? You see in the middle there's an open interval. And there's a different point indicated for that x coordinate. Do you see that? All right. So we're going to answer these questions. What is the output for the input 4? What does output represent? What coordinate? Why? Because what do? I input 5 to get my output 13. That's the whole function notation, right? Okay, so it's asking what is the y value when you input 4 into this equation? And you're going to read the graph. All right, so Locke, what do you think the output is when the input is 4? Okay, it's asking when the value of x is 4, what's the value of y? Are you on example 5? Yes, you are.
Yeah.
When x is 4, what's the value of y?
It's 3.
Okay, so look what I just did with Locke. When x is 4, what's the value of y? You see what I did? When x is 4, what's the value of y? And it's 3. So that's the coordinate pair, 4, 3. Make sense? All right, now we're given the output and we have to figure out the input. So Madeline, B, what is the input, what is the x value for the output for the y value 0? -3 and 2. Does anybody see one more? 0. There are 3 x values for when y is 0. Do you see them? It's the x-intercepts. Y'all, when y is 0, that's where you have your x-intercepts. Got it? Everybody hanging with us? All right. C. Leah, what is the y value that corresponds to x equals negative 2?
Is it 3?
Yes, it's 3. Why can it not be 1? Why can it not, that answer not be 1? Because at 1, it's an open interval. Got it? Okay, if we were to state the domain of that function, what would the domain be? Let's write it in interval notation. Okay, because we have closed intervals, we're going to start with the bracket. That means it includes. So what's the smallest x value? Graph. Smallest x value. Come on, ladies and gentlemen.
Negative 4.
-4, thank you. What's the largest x value? 5. Are any x values in the middle excluded? The answer is no. Because when x is -2, it does have a y value. Is 5 included in the domain? Yes, because it's a closed interval. All right? Now, let's look at our range in interval notation. What's the smallest y value? -2. Is -2 a y value? Like included or greater than? It's included. -2, so we have not the parentheses, but the box. And what's the largest y value? 3. And is 3 defined? Yes, it's not an open interval. All right, does that make sense? All right, then we've already talked about function notation. I've already taught everything else, so we're just going to go to example 6, function notation. And for that function, it's an H function. So most functions in math just have one letter that represents that function. So I use F, or most textbooks use F a lot of the time. But they will use H because they could be talking about height. And sometimes they don't use X and they'll use F of T because we're talking about time. So I see that a lot in the ACT, and we'll see it in our textbook. Particularly for physics questions, it'll use F of T for time. Y'all are in physics this year, right? All right, so let's work these practice problems. A, B, and C. It wants to know what H of the square root of 3 equals. Literally, I'm substituting the square root of 3 every place where X is. What's the square root of 3 squared? All right, do not be lazy and neglect to write this in the beginning. That's 3. That's supposed to be a 3. I wrote X. Plus the square root of 3 minus 2. So how do I write that appropriately in the proper order? How do I simplify that? What does H of square root of 3 equal? What goes first? Come on. Integers. Rational numbers go first. 3 minus 2. Irrational next. Imaginary next. That's the proper order.